This is the electric car problem, and if we read it, we have an electric car that runs on batteries that must be charged, and the charge has a certain cost associated with it. If it is at 12 a.m., the cost from 12 a.m. to 1 a.m., the cost is $50 or 50 units. And it moves on down from 1 a.m. to 7 a.m., 8 a.m. to 12 p.m., and then it moves on to military time, which is 1 p.m., 2 p.m., 3 p.m., and we work our way down until we get to the 23rd hour, which is 11 p.m. to 12 a.m., which kind of comes back to the 0 hour, and we have a cost associated with it. And our problem here is two-part. The first one is we need to code get charging cost, which takes in a start hour and a charge time, and you need to calculate how much that would cost somebody to charge for that many hours using that as your start hour. So let's go ahead and take a look at that one first, I guess. Let's say the start hour was 3 a.m., and the charge time was 8 hours. Well, we would look at our chart here, and we would look at 3 a.m. That's the first hour. That's the starting hour. So we would take 60, add it to 80, add it to 100, add it to 100, add it to 120, and work our way down until we get to 8 hours. So it'd be 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we would not add the 200, but we would add all of these costs here, right? And that should add up to 8 different hours. 1, 2, 3, 4, 5, 6, 7, 8. That's right. Okay, so that's the problem. And how do we solve it? Well, this little chart here is in an array, and if you look at our class, we have rate table, which is a 1D array of integers, and the indices represent the hours, and the placement in the array is the cost. So it's fairly simple. What we need to do is go into the int array, starting at the indices given as the start hour, iterate for charging cost number of times while summing up the costs. So let's go ahead and look at that in code. Well, it's right here. We get charging cost, start hour, and charge time. We create a cost variable that's going to sum up all the costs, initialize it to 0, and we for loop through the array, the rate table, and we use start hour as our initial indice, and we increment until start hour plus charge time. So this is going to iterate from 3 in our example. If start hour is 3 and charge time is 8, it's going to iterate from 3 up until 8, and it is going to sum up the values in the rate table. And of course, the trick here is you need to do mod the length of the rate table, right? Because the hour could go past the number of elements in the rate table. So for instance, if the start hour was 22 and the charge time was 8, then when we get up to the higher end, it would go to like 33, 34, 35, which is bigger than the rate table. But of course, when we go past 23 to 24, that gets us back to 0, right? So what we want to do as we're incrementing our counter, we want to mod by the length of the rate table, which is 23. And then in the end, after we sum them all up, we can return costs and we're good to go, right? So that's the first section. The second section is get charge start time, right? Where you give the method a charge time, and the method is supposed to return the optimal time to charge. Right? So let's assume our charge time is 8 hours. What is this algorithm going to do, or this method, what is it going to do? It's going to try to find the 8-hour block in the table that minimizes the cost. Okay, and the way we're going to do this is with a brute force algorithm. What we're going to do is we're going to do 0 to 7. That should be 8 hours. 1, 2, 3, 4, 5, 6, 7, 8. No, so 0 to 8. Is that right? 0 to 1. Yeah, that's right. 0 to 8. right? And that's going to sum up all of these. 50, 60, 160, 60, 80, 100, 100, and 120. And then it's going to compare that to 0 to 9. 1 to 9. And see which one is least. And which one is least is going to be the current minimum. And then it's going to do the same from 2 to 10, 3 to 11, 4 to 12, and so on as you're working your way through the table. And this is basically a min-max algorithm where you can set the very first set of 8 hours, set that to the minimum, and then as you work your way down the chart, if any of those sums of charging costs are lower than the first one, then you will replace the minimum with that value. So let's see how it's coded. We come over here, and this is one way to do it. Oh, I just put this here as an example of what a min-max algorithm would look like. Here we have a minimum. We set it to max integer, which is some huge value. And then for this if statement, max will be set equal to the first value in the array. Following that first statement, it's going to compare the next value with the max. And if it is, if the max is less than that array value, this should be min. If the minimum is less than the next array value, then it's going to set the minimum to that next array value. And if this while loop continues to iterate, then min will contain the minimum value in the val array. So that's essentially what we're doing here, except we're calculating the values in the array dynamically, because they are composed of sets of costs that are summed up together. So we can take a look at this here, and we have charge time, cheapest start hour set to 0, and we iterate through with our start hour initialized to 1, and we're iterating up to the length of the table. And we're saying if get charge cost of the start hour, which is 1, and the charge time, which in our situation here would be 8, if that is less than get charging costs of the cheapest hour to charge time, then we will set cheap start hour to the start hour. Right? And so what is that doing? That's comparing one set of sums to the next set of sums. And then this for loop is iterating through the entire array, so that all blocks of 8 hours would be accounted for, and we are picking out the one with the least cost. And at the end, cheapest start hour will contain the least cost. The start hour that would result in the minimum cost, and we return that value, and we're good to go. So that is electric car.